All right, let's see how we're doing. Today's warm-up was especially quick as far as time. That's done on purpose. I feel strongly that at this point you should find doing these multiplications to be fairly effortless. So let's see if that's the case. Number one, what'd you get? Start with Ania, Sebastian, and then Catalina. Okay. Okay. 9m squared minus 25. Could I have a volunteer tell us what this situation is called? What is this situation called? Kayla? It's called the sum and difference pattern. Very, very good. Number two, what did we get? Brandon, Kezekiah, and then Alyssa. Okay. So you agree, okay. 36n squared plus 36n plus 9. I have some volunteers remind us what this situation is called. So I got 1, 2, 3, 4, 5, 6 people who think they know the name. All of my students should know the name. Labari? Okay. Well, the way you said it the first time was not the way you were taught, but that is the same thing. It's a binomial times a binomial, but it's really the binomial times itself. And that's why the square of a binomial is important. Very good. Bless you. Number three, what did we get? Start with Maria, then Brian, and then Jada.
25b squared minus 70b plus 49.
Okay?
25b squared minus 70b plus 49.
So you two agree?
25b squared minus.
Okay, so we do have a slight disagreement, but it is 25b squared minus 70b plus 49. And Jada doesn't realize it, but she actually helped us, because she helped illustrate the biggest issue with the square of binomial pattern is that students forget that there is a middle term. This pattern, the middle term cancels each other out. In this pattern, the middle terms doubled. Okay? Number four, what did you get? Start with Kamoy, Alicia, and then Eric.
15x squared plus 2x minus 8.
Okay?
15x squared plus 2x minus 8.
So you two agree. What do you think, Eric?
15x squared plus 2x minus 8.
So all three of you agree, and that is correct. What is this situation called? Sharif?
It's just a regular binomial multiplication.
Very-
Formula.
Okay, so that was good. He read my mind. He's got magical powers. Because my next question was going to be, what method would you use? And he already said, FOIL it. Very good. So, comments, questions, concerns on any of these? Jada? Number two. What did you get? Okay. So what's happening is you're missing the middle term, because you also were missing it on number 3. Now let me ask you this. Are you using the shortcut? In other words, are you using the pattern to try and find the answer? What are you doing to find the answer? Okay. That's not how it works. Did you get number 4 correct? Okay. And what method did you use for number 4? Good. Now I want you to go back to number 2, and I want you to FOIL it using your colored pen right now. I'm going to come over and help. Any other comments, questions, concerns? Okay. For the last 3 lessons, the beginning of chapter 9, we have studied polynomials and 3 different operations: addition, subtraction, and multiplication. Now we're going to introduce the idea that you've actually been studying since the beginning of the year, but never with polynomials. And that is the idea of solving an equation that has a polynomial in it. for the first 6 months of the year, first half of the year, you studied linear equations. You, at this point, should be a master of solving a linear equation. Today, you're going to be now starting to learn how to solve polynomial equations. We're going to learn how to do polynomial equations that are in factored form. Now, I'm going to do something today that I started doing just recently. I never did before. And I'm trying to start each lesson, I'm going to give you an overview of what we're going to be doing, what you're going to be seeing. Excuse me. My goal is to give you kind of a quick snapshot of our goal so that you have a sense of where we're going. So you are not to copy this. This is something for you to look at. You're not supposed to understand, but you're supposed to have a picture in your mind of what you're going to be doing, and so that's to help you see what the process will be like. So here's an example of solving an equation in factored form. We're going to be doing this example later on, but I wanted to show you the end product. So this is the type of work we're going to do. Here is the equation. Here is one part of it. Here's another part of it. And here is the solution. In fact, there are two solutions, and you can see them there. So what's different today is that we are now doing an equation. We're not simplifying expressions only. Here's another example, and this is going to be the harder part for today. Because you're going to, for the first time, learn how to factor a polynomial. So here's the original question. This is not in factored form. And then we have to go through a process of getting it into factored form, and then we solve and we get two solutions. So this is the type of work you're going to be doing today. So now, of course, I break it down step by step, component by component. So let's go back to the beginning. Solving a polynomial equation in factored form means we need the equations in factored form. Factored form means it's written as the product of two or more linear factors. So that's the key, is that we will take polynomials which are not linear. They don't form lines. You're going to see that. You're going to see why in a minute. They don't form lines, and we're going to convert it so that it's the product of linear factors, factors that will produce lines. Why? Because we know how to solve these. We know how to solve those. Here's an example. Here's a polynomial. 14w squared minus 21w. That squared is what changes everything. You have no idea how to solve that. You never learned. And it's much more complicated than what you've learned in the past. That one detail is what makes this nonlinear. Today you're going to learn how to do this. It's the same thing in factored form. You can think of it kind of like making change with money. You want to go to the vending machine, but you have a $1 bill. You ask for change. Hey, does anyone have 4 quarters? Because the 4 quarters allows you to do something with the money that you couldn't do with the $1 bill. So converting from one form to another gives us an opportunity to do something that we couldn't do otherwise. Here's another example. A trinomial. This is the polynomial, and then you see that it's got exponent of 2. That one exponent changes everything. Here's what it looks like in factored form. Z plus 9 is linear. Z minus 8 is linear. We can solve those. So that's our goal today, is to be able to to be able to convert from a polynomial into its factored form and to solve an equation that's in factored form. Okay? Any questions so far? Good. Now, there is an idea that allows us to actually do this, and it's called the zero product property. If you have two numbers that are being multiplied, and you know that the result is going to be 0, then one of the numbers must be a 0. So, for example, if I said x times 5 equals 0, what must x be? Anissa? Must be a 0. It's the only possible number that will work. So it works with anything. It could be fraction, decimal, doesn't really matter. If I did 1/3, 1/3 x equals 0, what must x equal? Come on. 0, it has to. Now if I wrote x times z equals 0, well, we don't know what x is and we don't know what z is, but we do know that, Catalina, one of them, at least one of them, has to be a 0. Okay? So this is the property that allows us to use something like this and actually solve an equation within it. And you're going to see this in practice in a little while. Okay? Brandon. Well, what's your other option? Just give me an example.
X z times t.
Okay. Oh, no, they could both be 0. Yeah. This could be a 0. This could be a 0, and that would equal 0 as well. That's why I said at least one of them has to be a 0. Okay? Yeah, you're right. All right, so now the real-world application of this is going to be something we're going to use starting today for the rest of the year. You already memorized it. Today you're going to learn what the different letters mean. And it's the vertical motion model. You already learned that h equals negative 16t squared plus vt plus s. You already have that in your mind. But what you didn't learn was what's the h, what's the t, what's the v, and what's the s. What is the vertical motion model? The vertical motion model is used for objects that are flying through the air. So, t is time in seconds. The time that the object's going to be in the air. The v, this is the really important part that makes this something pretty new for you. This is called the initial vertical velocity. You can think of it kind of like speed, but it's initial vertical velocity. Feet per second. The s is the initial height, the starting height of the object. And h is the ending height of the object. So that's 4 different variables. To solve an equation, we need to have only one variable, or with a system, you learned how to do 2 variables. But we're not talking about systems today. So we will need information for 3 of these variables to calculate, or I'm sorry, to solve for the 4th. And that's something you're going to learn how to do today. So, the vertical motion model. Do I have any people in here who can catch a ball with pretty good confidence? Okay, so put your pencils down for a second. So, vertical motion model is about this, or about a soccer ball being kicked off the ground, okay? Or a rocket being launched. I mean, it applies to a lot of different things. So if I take this ball and I throw it to Hezekiah like this, keeping it up, okay? He caught it like that. Here's where it left my hand, right here. The initial height, S, is the distance from the ground to where the ball was in my hand. So we would need that piece of information. Where the ball is right now is its ending height. So we would need that piece of information. The last piece is hard, because we would actually need a machine to calculate it for us. And that's the force with which I threw the ball. So throw it back. Thank you. So this force, the initial vertical velocity, is the other piece of information we need, okay? Because I can throw it really fast, or I could throw it like that, and that will affect how long it's in the air, okay? So here's the thing, is that we can actually predict with pretty good accuracy how long it will take the ball to go from here to there with those pieces of information. Soccer ball, and we're going to pretend this is a soccer ball. If it's on the ground, and I'm going to kick it, and those of you who play soccer know that usually if you kick it right, it actually goes up into the air and goes in a little bit of an arc and then will come down. Well, there's a bunch of things that could happen. The player that you kick it to could chest the ball like that, and so that's the height that it ended. Or it could hit the ground. So if it hits the ground, what would we call that as far as the ending height? What's this height? What is that height right there? That's 0. So what if I kick the ball from the ground, let it go up in the air, but then it hits the ground at the end? It started at 0, and then it ended at 0. And so those are pieces of information that we're going to use to actually predict how long the ball will travel in the air. But the piece of information that we would need some sort of device to calculate is how hard I kicked the ball. With what force did I affect the trajectory of the ball? Yes, and then yes.
Wouldn't the ending height always be 0 because gravity wouldn't be
Well, was it 0 when I threw the ball to him? Turn around and look. Is that 0? Okay, so we could actually predict, let's see. That looks like it's about, I don't know, maybe 3 feet, 3.5 feet off the ground. Okay? So it really depends. We're talking about specific, you got to be very specific with the situation. I apologize, I forgot there was somebody else who had a question. Brandon, go ahead. Okay, well, how would that happen? I guess we would have to experiment with that. I don't know. Or if something so heavy went up in the air and then actually indented the ground. Yeah, I'm not sure. I guess that would have to be negative. Yeah, you're right. All right, so this is something we're going to use towards the end of today's lesson. This is what we're leading up to. We want to be able to solve situations that involve the vertical motion model. That's our ultimate goal. So let's start putting this into practice. But I want to show you something first. Put your pencils down. You're not copying this at all. This is another overview. These are things you're going to learn in the future. But the first thing all the way on the left should be the most eye-opening. Okay? So I want you to look at this picture. This is a graph of this. You're going to learn how to do that in Chapter 10. You're going to literally be drawing these from scratch in Chapter 10. But I want to show you something. Here are 2 examples that I've done so far. How many solutions are there in this first one? Sharik?
2.
And how many solutions were there in the second one?
2.
Okay, and so now let's look at this graph, and what do you notice about the graph? What do you notice, Ania? Where are the solutions? I'm talking about the graph itself, so we're looking at this picture. Well, I'll tell you what, you're right, there are 2 solutions, but what I'm asking is, where are they? Yeah, you need to know that word, don't you? Kayla will help you out. Yeah, where the graph crosses the x-axis, those are the solutions. So how many times does this cross the x-axis? It crosses twice. So there are two solutions. When you studied linear equations, when you studied lines, here's what the graph looked like. We did graphs like this. Right? How many times did those cross the x-axis? Sebastian? Once. You drew lines like that, you drew lines like, vertical lines, you drew lines that weren't like that, but no matter what, they all crossed once. Now we're drawing pictures, graphs that cross twice. And that's why there are two solutions. So today you're learning a method for finding the solutions without having to draw the graph. In Chapter 10, you're going to learn how to draw the graph and find the solutions. You are also going to learn how to use this, the quadratic formula, which you already have memorized, but now you're going to learn how to use in the next month or so. This is another way of finding solutions. And lastly, in the future, you're going to learn how to use square roots to find solutions. When you take the square root of a number, you end up with two different possibilities, and those are also the solutions to the equation. So here are three methods for finding solutions that you're not learning yet. I'm teaching you the method called in factored form. Okay? Comments, questions? All right, so now let's explore today's idea. Solving an equation in factored form. Today's lesson is going to start simple and then move to the more complex. I've told you at times that I will start with the most complex and move to the simple. That's not the case today. So we're going to solve this equation. Before we do, I want to do something that I don't want you to copy. But I just want to demonstrate something that we could do if we wanted to. Here's a binomial times a binomial. I could now FOIL it if I wanted to. I could FOIL it. Okay, 7x times 5x, 35x squared. The outer is, 70? That's 105. And the inner is negative 10, so that's 95x and minus 30. Equals 0. So I could do that if I wanted to. But I do not know how to solve an equation that has that. So if I do that, then I'm stuck. So let's back up. I don't want to do that. I want it in factored form. I want it in the form that it's in right now. Because that I know how to solve. Let me show you how that's true. What if I asked you to solve that? Give me a thumbs up if you can solve that. Yeah, not only should you be able to solve it, you should be able to solve it in 10 seconds. Put your thumbs down. So that's actually what we do. We use the zero product property, and what we do is we pretend that one of these is nothing. And then we solve the other one. Then we do the opposite, and that's how we end up with our two solutions. So here's what we're going to do. We take the first binomial and set it equal to 0. 7x minus 2 equals 0. We're going to take the second binomial and set it equal to 0. 5x plus 15 equals 0. Solve both equations. Add 2 to both sides. 7x equals 2. Divide by 7, divide by 7. We get x equals 2/7. Do the other one. Subtract 15, subtract 15. 5x equals negative 15. x equals negative 3. Now I have my two solutions. So the solutions are x equals 2/7 and x also equals negative 3. Because those are the two locations where this will cross the x-axis. Does anyone have any questions or comments at this point? When you get to chapter 10, you're going to learn how to graph from here. You can't really graph this from here. This just tells you where it crosses the x-axis, but it doesn't show you whether it goes like this, it could go like this, it could be thin like that, it could be very wide like that. So it doesn't show you any of that. That I'm going to teach you in chapter 10. This only tells you the 2 points where it crosses the x-axis. Okay? Brandon? Okay, it is a bit complex. So I'll get back to that towards the end when we've gotten through the process. Okay? Just don't forget your question. All right. Part B. Square of a binomial. So if I wanted to, I have a shortcut. I could multiply that out and I could get another polynomial if I wanted to. But that won't get me anywhere. I want it in factored form. This is factored form. And what it really means is this. It's the same binomial times itself. What do you think we need to do here? Tristan? Yeah. We just need to do one of them, because it's the same thing twice. So we really just need to do x minus 9 equals 0. In fact, it takes no effort whatsoever. X equals 9. Now, Mr. Gallant, you said that there are 2 solutions, and now I've got 1. So I don't understand. Now, Tristan said that means you had the same one twice. But if you think about the graph, well, wouldn't that mean it's just crossing at the same exact point? So how would that work? Anyone have an idea? Ania? I'm sorry? I just can't hear you, that's all. Okay, well I could plug it back in, and I would end up with a 0 times a 0, which equals 0. So we know that that's a solution. My question is that I've showed you 3 or 4 different ones that all had 2 solutions, and now this has 1. And I pointed out to the graph that the graph crosses twice, and that's why there's 2 solutions. And now I'm asking, if there's only 1, what kind of graph are we talking about now? So Sharik, you have an idea?
Yeah, maybe like at the very tip of the graph, but like when they connect those 2 points,
Mm-hmm.
I think maybe that's where the x intersect, the coincide with each other.
Well, let's find out. So, yes, very often when you graph these, you will cross the x-axis twice. But if the vertex is the point where the graph touches the x-axis, then we only have 1 solution because it only crosses 1 time. And that's what Sharik was trying to describe. This is the graph of that equation. Comments, questions? There was no way for you to know that. I just wanted to see if anyone had an idea. Yep, and then yeah.
On the graph, at like the tip, like where it curves, wouldn't it also be touching like the other points?
You're saying kind of like right next to it here and right here. I know it looks like that because I made the line a little bit wider so that you would see it, but technically it's only crossing at that one. It's a good, you make a valid argument, but it's technically only crossing at one point.
How do you have the slope of
Slope doesn't have slope, not the way you think. It's different, and we'll learn all about it when we get to chapter 10. Okay? All right, so last example for now. Well, you've seen two different cases. What do you think we do now for this case? Think about it. And what do you think we're going to have to do in this case? I'm sorry? Okay, well, we actually can't. We're not allowed to because they're being multiplied together. So we're not allowed to do that. Okay, again, we could simplify, we could multiply it out, but as I demonstrated before, unfortunately that makes it very difficult to solve. So we're trying to figure out, based on what you've learned just in these two examples here, and here, if you just think logically about it, what do you think is going to happen next? Data? Yeah, we're going to set each factor equal to 0. So how many equations are we going to have to solve? Bless you. How many equations are we going to have to solve in this one, Jada? 3. So in the first one, we had 2 factors. That's a factor and that's a factor. We had 2 equations and we got 2 solutions. Here we only had 1 factor times itself, so we had 1 equation with 1 solution. Now we've got 3 separate factors. We're going to have 3 equations with 3 solutions. So 7x plus 3 equals 0. 2x minus 1 equals 0. X plus 5 equals 0. Solve each one of them. You should be able to solve them pretty darn quickly at this point. You might even be able to use some creative mental math to get through this. Shouldn't really have to put too much thought in. Catalina, yeah. Well, we're going to find out in a moment as we explore that as well. So now we've got 3 solutions. X is negative 3/7, 1/2, and negative 5. 3 different solutions. Now, Catalina already asked me the question that I was going to pretend to ask myself. You say, well, Mr. Gallet, you said that they always have 2 solutions. Then you blew my mind because then you showed me one with 1 solution. Now you're showing me something with 3 solutions. What is going on, Mr. Gallet? It's very confusing. So, what was your proposal, Catalina? That it was going to be what? All right, so let's take a look. So here is what the graph looks like. If my computer will cooperate. I apologize, I have no idea what happened. Let's try one more time. All right, well, I'm not sure what happened, but I can't seem to get it to work. But yeah, she was right, actually. It is actually a line, it is actually a graph that goes like this. And it crosses the x-axis 3 times. If I can get it to work a little bit later, I will show it to you, okay? And I had intended to show it to you. So, yeah, every solution represents a position where the graph crosses the axis. That's what a solution is. Yeah? If you go back and watch, you'll start seeing a little more clearly now what he did do. What he did was much more complex, but now you have a better idea because now you have more components to work with. You, up until this point, only had straight lines to work with, and now you have curves that you can work with. And that's what he needed to create the Batman graph. You're going to learn that when we get to chapter 10. How do you know which way the line's going to go when you do a linear equation? What is negative? You're close. The slope, that's right. If the slope is negative, it goes up to the left. If it's positive, it goes up to the right. So it's going to be something like that. Okay? Very good question. All right, so let's see how we're doing so far. Checkpoint number 1. You got one equation to solve. You got 3 minutes to solve. All right, colored pens, and let's see how we're doing. What'd you get for your solutions? You got Kamoy, Brian, Sharik, and then Diana. Okay. You agree, okay?
D equals negative 2.3 and 4.1.
You said negative 2.3? Okay, so you guys agree. Okay, so we all seem to agree that D equals negative 2.3 and 4.1. So, I did this example on purpose. This is a higher level example, and it's designed to give you practice, but also to illustrate a couple of points. You learned in the second example, part B of the last example, that this, when you're talking about solving an equation, actually does not matter, because it doesn't matter if there's two of these. You're still going to get the same solution. You're just going to get the same solution twice. So in actuality, that had no purpose whatsoever. Did anyone discover anything else that actually serves no purpose whatsoever throughout the entire process? Two people have an idea? Sharik?
The coefficient of negative 8.
Yeah.
Even if you distribute it, it still gives the equation.
Yeah. It actually plays no role whatsoever. And I'm going to illustrate to you why. Okay? First of all, you cannot distribute this, because this exponent forbids that from happening. You could have distributed here and here if you wanted to, but you would be wasting your time. And let me show you why. Everyone pick a side of their paper with their colored pen, and we're going to do this. X minus 2 equals 5. Solve that mentally. What does x equal? Someone raise their hand and tell us. What does x equal? Eric? 7. We all agree that it's 7? Good. Now watch this. Solve the equation. Do it right now. Do it mentally or do it on paper. Either way, I don't care. It should take you 30 seconds or less. What's the solution? What do we get? Ania? You know what? Something's not right. What did I do? 3x minus 6. Now I feel like I'm messing something up. Oh, I'm sorry. I did mess up. I didn't multiply the other side by 3. My fault. So if I multiply this side by 3, I'd have to multiply this side times 3. I apologize. So it's my fault. Totally my fault. Reset, and let's go back. Try it again. So what will we get there? I kind of blew it. I kind of messed up the process, but what do we get?
7.
We get 7. So if you get 3x minus 6 equals 15, you solve that, you end up with 7. So when you multiply both sides of an equation by a number, it doesn't affect the process. So if I multiply this side by negative 8 and multiply this side by negative 8, does it change anything? Because this is going to stay a 0, and this is not going to change anything, as I just proved over here. Although I didn't really do a very good job of proving it, but I proved it. Okay? So the point is this, is that the negative 8 is not really a factor that needs to be considered. The only factors that need to be considered are the ones that have the variables in it. A numerical factor is not going to play a role in these equations. Come on.
I distributed this one versus
You got a little bit lucky. You're not allowed to distribute when you have an exponent on the outside. You can't distribute to that. Okay? So, comments, questions, concerns? All right, so now to the more challenging aspect of this. When you're faced with a situation that is not already in factored form, what can we do? If you're feeling tired already, if you're feeling like you've been stretched a little bit, you got to buckle down, because this is where the real challenge is. So, 6x squared plus 12x equals 0. We do not know how to solve that. We have not learned how to deal with this exponent yet. You're going to be learning how to deal with that in a different way later on. But we do have a method at our disposal. If it's in factored form and the factors are all linear factors, then we can solve it. So the question is how can we turn this into factored form? And so this is something new that you're going to learn. That it's actually not new. You already know how to do it. You've just never done it in this direction. We're going to use the distributive property. But we're going to use the distributive property going in the direction that you never went before. You're used to doing this. You're used to doing distribute, distribute. But what if it was this, and I asked you to change it back to this? What's the common factor between this and this? In other words, what do they have in common that can go out here like it is over there? Should be clear because I did the same one. Alicia? Yeah. So if I take this 8 out and put it here, then what would be left over? In other words, what would have to be right here to get this? There would have to be an x. And what would have to be right here to get that? There would have to be a positive 1. And so that is going in that direction. Now I know how to go in reverse. So we're going to do the same thing with more complex situation. We're going to do this in a way that will hopefully allow you to start using your brain creatively. So we've got the 6x squared plus 12x. We're going to rewrite that. We're going to break down the 6x squared into factors. So this is going to be 2 times 3. That's 6. Times x times x. That is 6x squared. Now, the 12x. Let's break it down. What prime numbers would I use to multiply to get 12? And? Very good. 2 times 2 times 3. That's the 12 times the x. And then, of course, the whole thing is equal to 0. Now, look at both products. Look here. And look here. Find the factors that they have in common. So give me one factor that they, I'm sorry, let me get set up first. Now, we're going to find the factors that they have in common, and those are going to go on the outside. And what's left over is going to go on the inside. So give me one factor that they have in common. One factor that they have in common. Eric? They have a 3 in common. So the 3 is going to go out here. Give me another factor that they have in common. Tristan? They have a 2 in common. This 2 and this 2 they have in common. What else do they have in common? Alyssa? They have one x in common. This one and this one. Do they have anything else in common? Okay, so all the things that they have in common become the factor on the outside. So now 2 times 3 times x. What will that expression become? Kamoy? 6x goes on the outside. The part that I have not highlighted in green is what's left over. That will go on the inside. What will it be? Kayla? Well, do it in order from left to right. X plus 2. So the goal by breaking this down into this was to find these common factors so that that could be a common factor that sits on the outside of the distributive property. That's what it is. It's a common factor. So what we've now done is we've rewritten the equation into factored form. So that was new. The rest is old. The rest is doing this, this, or this. Is setting each factor equal to 0 to find the solutions. So we have two factors. We have 6x. That's going to get set equal to 0. And we have the other factor, x plus 2. That's going to be equal to 0. And now solve both of them. X equals 0, and x equals -2. And so the two solutions for this equation are 0 and -2. Okay?
2x is 6.
Okay. So the problem is, and that's fine, and you will end up with the same answers, but the problem is that we want this, and you're going to see this phrase in the textbook. We want the greatest common factor. We want the greatest common factor. That's what that is. The greatest common factor between all of them. So you can find a common factor, but there's going to be cases where you won't be able to solve it then. Okay? It has to be the greatest common factor. Guys, I know this is a lot to take in. You're learning a lot of things all in one lesson. You gotta have your brain in the highest gear possible. Okay? So take it one small step further. One major thing that all of these equations have had in common that you may not have really paid attention to, but they all have a 0 on the right. We can only solve them when they have a 0. Otherwise, we can't solve it because that's the zero product property in action. So this had a 0 on the end. This had a 0, this had a 0, this had a 0. They all had zeros. And so now we don't have a 0. So we have to get the 0 there. How can we get the 0 on the right-hand side? Got 4, 5, 6. Brandon? Yeah. We'll subtract 21y from both sides. And we will rewrite the equation 9y squared minus 21y equals 0. Now we have the 0 on the right. Now we can try to put it in factored form. Now I'm going to break this down again with your help, but the goal is for you to be able to do this mentally. So could someone break this down for us into prime numbers and all the variables? What will it be? Hezekiah? Very good. 3 times 3 times y minus, and what about the 21y? What will we rewrite that as? And? Very good. 3 times 7 times y. And now we will be able to do this. So what will the common factor be that we're going to pull out and put on the outside of our distributive property? Tristan?
3.
That's not the only thing they have in common. They have a 3 in common, so that comes out. And then they have 1y in common. You have to actually count how many they have in common. And so 3y is what is going to come out. What is left over? 3y is left over here minus 7. Now we have the two linear factors. Now we can solve. 3y equals 0, and 3y minus 7 equals 0. Y will be 0 and 7/3. Comments, questions, concerns? Ania and then come on. I'm sorry? No, you can put it in a mixed number. If you're talking about an x-intercept, that's fine. Come on. That's a method for finding the greatest common factor. Is if you look at prime numbers and then just get all the prime numbers that they have in common together, that will give you the greatest common factor always. It's not the only way to do it. I mean, I at this point can look at them and I can say, okay, they both have a 3 in common and they both have a y in common. I can just look at it and know. My goal is for you to get to that point pretty quickly. But for now, I'm trying to help everyone by showing you the breakdown. Okay? All right. Let's see how you do on your own. You give it a shot. You work hard. You learn from your mistakes. You got 3 minutes. What'd you get? 1, 2, 3, 4, 5, 6, 7. We'll start with Jada, Catalina, Brian, Sharik, Hezekiah. Okay?
5r times r -6
Okay. Okay. What'd you get?
Oh, I actually solved it and I got r equals 0 and 5, 6.
Okay. So we have a little, they all agree. Okay. But correct. Let's skip you. Go ahead. What was yours?
5r times -6
Okay. R is 0 and 5, 6. So I was expecting this to happen because you focused on something new and you didn't follow through on what the goal is. It says solve. So let me go back for a second. This process from here to here did nothing. That was turning the dollar bill into 4 quarters. That was it. Now you got to use the 4 quarters to do something. What was the point of converting to 4 quarters? You wanted to go to the vending machine to get a drink. So you needed the 4 quarters to do something with it. You have to do that last part, which is now solve the equation. We're trying to solve. So everything that you guys said and you all agreed upon, that was correct. That was a step. You then have to solve. Okay? Are there any comments or questions about that? Absolutely. Absolutely. That's not even close. Because that's like saying this. If I asked you to solve this, and Marie, I'll get to your question in a second. 3x minus 17 equals, let me try and pick something that will work. I don't know if this will work. 4th. So let's pretend you're the teacher. You're the Algebra 1 honors teacher. We're in chapter 3. It's a quiz. This is question number 2, and this is what I do. You mark it correct?
No.
No. Because what was I supposed to do? I was supposed to find what x is equal to. Did I do that? No. So I'm taking a moment to illustrate this because I think a lot of my students get stuck. Because right now, you've got so much going through your brain, you don't know what's up and what's down. And so one of your jobs is to start working it out and keeping it straight. It's not easy. And it's going to get harder and harder. Okay? Good. Any comments or questions about that? Maria, you have been waiting patiently.
I still understand. You get the equation to simplify. I understand where you put the negative. Because like you could just go -5 and 5 and have -5r. I still understand where you put the negative.
Okay, well, what did you put?
I put -5 times 2 times 3 times 4 times r plus 5 times 5 times y equals 0.
Okay, all right, hold on a second. Let me get to where you're at. So we have -5 times 2 times 3 times r plus 5 times 5 times r. Okay, so here's the part that you aren't sure about. Is that we're looking here, and we're looking here, and we're saying, well, that's not the same number. So what's the one step that I should go further so that then I can see it? What's the one step that I should go further so I can see, so Maria and I can both see it? Moy? Move it how? Okay, so what she's saying is I can take this negative sign and actually move it over here, and I'll get the same value. Or I can move it over here, and I can get the same value, but I'll take it one step further. What if I move it here, and I put this? So now we have the 5 and the 5 and the R and the R. Okay? Now you had never seen that before, so Maria, of course, how would you know? That makes perfect sense. But now you're seeing it. Now you know that this is really just a -1 times another number. Okay? Does that explanation make sense to you? It's okay if it doesn't. I'm just asking if it does. Okay. Give it some time. It'll start to sink in. Okay? Good. The ultimate goal, and I had said this when I introduced the vertical motion model at the beginning, the ultimate goal is to be able to solve real-world scenarios. And to be quite honest, we've done lots of real-world scenarios over the course of this year, but this is the first time that you're really going to experience a real-world scenario that you could really envision, you could actually test out physically if we had the equipment that we would need. It seems to me a little more accessible than some of the other ones we've done. So, you do not have to copy, but of course you're reading along with me, and we're going to work through one of these together. And the idea is for you to learn what's going on, and then take it to the next level, and be able to apply it to other situations. So, I've already given it away that this is a vertical motion model question, but it does not say anywhere to use the vertical motion model. What's the giveaway? Other than the fact that I put it in parentheses, but looking at the actual question, what's the giveaway? Maria? Yeah. When you're given a piece of information that says initial vertical velocity, that's a clue. Now, just to make sure we're understanding the question is that if I jump rope, and hopefully at some point in your life you jumped rope, that you are starting on the ground, you jump up over the rope, and then you land on the ground. So the question is that if my initial vertical velocity is 8 feet per second, or if the child's is 8 feet per second, how many seconds will it take for the child to go back up into the air and then back to the ground? So we are going to use the vertical motion model. You should have it in your mind already. You shouldn't have to wait for me to write it out. So you should be writing it out already. H equals Now, you did write down what the letters mean, but that's not good enough. It's not good enough to just have it written down and be able to refer to it anytime you want. You have to know in your mind what each of the letters means, because you have to pick out information from the text and put it into the question, into the model, so that you can then actually do something with it. We are being asked to find a number of seconds. How many seconds? Which letter is represented by that? Melissa? The T. So the T must stay. The T must stay, because that's what we're trying to find. That's the missing piece. But that means that we have to fill in the S, the V, and the H. And all of that has to be filled in from information here. Let's start with something simple. And we'll fill in one piece at a time. 8 feet per second is the initial vertical velocity. Where does that go? 5 people can tell me where it goes? Oh, a whole bunch of people. Shelby? Very good. So it's going to go in place of V. So this term is going to become 8t. Now, the negative 16t squared is not going to change because there's no variable for us to put something in. So this is going to be negative 16t squared plus 8t. The equal sign is going to be right there. Now we need something for h and we need something for s. So what can we put in? Pick one letter and tell me what you think. Jada? S is 0. What does S stand for? Very good. Why is it 0? Very good. That was a beautiful explanation. S is 0 because we're starting on the ground. You've learned in math that when it's 0 and there's other terms or anything else on the same side, we don't need to write it. We just now know that that's going to be nothing. What about H? What's H going to be? Kayla? 0? Why do you think it's 0? Say it just a little bit louder one more time. Very good. When she's done, she's going to be on the ground. So this is 0. Now, this should look familiar to you. I mean, you've seen this already a few times. It looks pretty similar to this, similar to this, similar to this one. So now we have an equation that we actually do know how to solve. We need it in factored form. That's the only detail we need. So we're going to convert this from this into that. So let's see if we can now use our brain creatively without having to write out the prime factors. Let's see if we can figure out what number we can pull out that's in common with these two. What's in common? 4 people able to do it? 7 people? 8 people? 10 people? Alicia? 2 they have in common. Is that the largest number that they have in common? Okay. 8, they have an 8 in common? Absolutely. 8 is a factor of 16 and 8 is a factor of this, so the largest numerical factor is 8. What about the variable factor? What's the largest variable factor that they have in common? Hezekiah? T. How many?
1.
1. That's right. There's 2 here, there's only 1 here. That means they only have 1 in common. Now I need the inside. 8t times what will give me negative 16t squared? Come on. Negative 8t plus 8t will give me 0. I need what's going to... This times this will give me this. Negative 2. That's right. Negative 2t. 8 times negative 2 is negative 16. T times t is t squared. 8t times what here will give me the 8t. Sebastian? 1. So that's the inside. So we've converted the dollar into 4 quarters. But now we have to do something with the 4 quarters. And so now we need to solve this. 8t equals 0. Negative 2t plus 1 equals 0. Solve them both. You get t equals 0 and t equals what? Right? 1/2. So we get 2 solutions to the equation, but now we need to answer the question. After how many seconds does the child land on the ground? Is it both of them? Is it 0 and 1/2? What is the answer? Tavares? I think it's a half. Catalina, what did you think? I think it's a half. Right? 30 seconds, okay. Anif? Half a second, okay. Half a second is cut. Okay, but not 0. Why not? That was actually a phenomenal, beautiful explanation. That was perfect. Because it can't possibly be 0. Because the child in the story is going to actually leave the ground. Time must go by. it can't possibly be 0 seconds. So half a second is what we are looking for. So that is using the vertical motion model. I mean, really all we're talking about is having something in your mind that you can fill in with information and then solve. Okay? Any comments, questions, or concerns? All right, we're doing well. Draw a line across your paper. Your classwork is on page 95. You're going to do 35, 32, 29, 26, 19, 12, and 10. Solve to get these solutions. All right, let's get our color pens up and let's see how we're doing so far with solving equations. Number 35, all it did was break down the process into 2 steps. Number 32, you get 2 solutions, -1/2 and 0. Unfortunately, if you get 1 solution correct and 1 incorrect, the whole thing is wrong. You need both solutions correct. Yes. 0, negative. First of all, that's not really a comma, and I actually don't like that the publisher used a comma, because I think students start thinking this. That's not the same thing. So we're not talking about an ordered pair, so in this case it doesn't matter whether you got the 0 first or last. I prefer to use a semicolon. That makes it more clear that we're just talking about 2 separate solutions, okay? But you, good. No, that's fine. All right, number 26 and 19. Now, number 19 said, what's the greatest common monomial factor? It's the monomial on the outside is the 5q. I'm not sure why the publisher then went ahead and put that as the solution. I didn't really catch that until a lot of people were asking me about it. So this is really, I believe, what we were looking for, but if you wrote this whole thing, that's fine as well. And the last 2. So, comments, questions, issues, concerns about any of these? Start over here and then here. Go.
For 12, like, I got it wrong, but I get why, because I thought it was the square of a binomial, but then I realized it wasn't when I was the answer. So, for that, can we just, like, solve one and then just change the
If you can recognize that that's what's going to happen, why not? I mean, what's my policy been since the beginning of the year? If you can give me the correct answer, I don't really care how you do it. I even joke and say, if you want to use magic, use magic. But my point is that You guys are very bright, and some of you can see things that I can't see. And if you can see something that I can't see and that can make you successful, then use it. Okay? 1 second, I got Maria and then number 32. Okay? Your question just where it came, like where these answers came from? Okay, so let's survey the class. Give me a thumbs up if you got number 32 correct. Keep your thumb up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Good. So about 2/3 of my class got number 32 correct, which means that out of about 7 or 8 people, Maria was only brave enough one to ask. So, Kisara, what was the first thing that had to happen in number 32 before you even really started doing anything else? Wow, you said that beautifully. You had to get the side to 0, so we have to add 15r to both sides. So this becomes 0. And so we get 30r squared plus 15r equals 0. Okay? Give me a thumbs up. Anybody in the room, give me a thumbs up if you did that step. Okay, Zabara, you didn't do that?
No, I did not.
Oh, okay. Put your thumbs down. All right, so now this is in polynomial form. We don't know how to solve this yet. So we need it in factored form. And what I taught you was you can change this into a monomial factor times whatever's left over equals 0. So this is going to be the GCF, the greatest common monomial factor. So you have to look here and say to yourself, okay, well there's a 30 and a 15. What is the biggest number that they both have in common as a factor? Anissa? A 15. So you know that there's going to be a 15 here. And then there's 2 r's and then there's 1 r. They have only 1 in common. So we're going to have an r here. And now you say to yourself, okay, 15r times what will give me 30r squared? Start with the number. 15 times what gives me 30? A 2. R times what gives me r squared? An r. Now 15 times what gives me, 15r times what gives me 15r? 15 times what gives me 15? A 1. R times what gives me r? The 1. And so now I have it in factored form. Give me a thumbs up if you had that step. Good. So now set each one equal to 0. 15r equals 0, and 2r plus 1 equals 0. Has anyone noticed anything about all of these questions? They all have one major thing in common at the end. Got some frantic people raising their hands. Kamoy?
For the, it's always 15r, like, r, it's always 0.
Yeah, there's always one solution to 0. When you have a monomial factor equal to 0, this is always going to be 0. So if you look back at all the answers, look at the answer page. I mean, if you didn't pick up on it, got to get your brain in gear. 0, 0, 0, and the only ones that didn't were the ones that didn't have monomial factors. This has a binomial factor, binomial factor. Binomial, binomial. Those factors turn out into numbers. Okay? So, any follow-up questions on, and I'm sorry, this comes out to r equals negative 1. Any follow-up questions? Zavari? Number 19? Well, I'm running short on time, so let me take a quick look. Okay, so here's the case where you need to separate everything into its prime factors. So watch, if I did this, does that make it a little bit easier to see? Now you try to find, what do these two monomials have in common? They have a 5 in common, and they have, nope, not a letter P, not a letter P, not a number 2, oh, a Q. They have a Q in common. And that's the greatest common factor. Okay? All right, I'm short on time. I apologize for that. Draw a line across your paper, your homework. It's page 596. That's 12 through 42 even, 52, 54, and 56. You have 2 days to do this assignment. I highly recommend doing some of it tonight, some of it tomorrow night. That way, if you do some of it tonight and it's not making sense, you can come to my care class. You will have a quiz next week. I'm not sure which day yet, but it will be on 9.1 to 9.6, which of course we haven't finished.